Good morning, everyone. I'm Bowen. Today, I'd like to introduce the dual path neural network for image classification. Okay, convolutional neural network has been the backbone of the computer vision for over 10 years. They have driven significant advance in image classification, object detection, and segmentation. However, heavy dependence on convolutional neural network might limit trying out other algorithms, potentially slowing the innovation. The main problem I focus on is image classification algorithms. Image classification is a fundamental task in computer vision, where the goal is to categorize the images into pre-defined classes or labels. The input is multiple images, and the output is probably of each category. And each photo only have one class. It's used resets normalization to improve the model performance. We evaluate the model's performance on the new images using the top 1 and top 5 accuracy. And we also use the train loss, test loss to compare the different kinds of the models. Okay, let's move on. In the next part, I'd like to introduce the baseline model. First, let's compare the AlexNet and LeNet. AlexNet introduced a new activation function, ReLU, instead of the sigma, which made the training faster and reduced the vanishing gradient problem. It also added dropout, which later algorithm didn't use as much before the Vision Transformer. That means the convolutional neural network didn't usually use it, but the Vision Transformer, Swing Transformer, and Transformer, they usually use it. This is because this algorithm, the basic of this algorithm is transformer. Okay, and the algorithm increased the both network depths and training data set. What means network depths? Network depths like here is the block, one block, and the network, and combine and this is next block, third block, and combine these blocks together as an algorithm. This is the depth. The depth means that you have a lot of block. And the training data set, you means that the AlexNet use the ImageNet for training data. They means that have 1,000 classes and many images. And the older network could not have many layers until the ResNet. That means the input of the AlexNet have 3 layers, and however the LeNet only have one. What's the layers in this part? This layer means the RGB layer. Like the AlexNet, the input of AlexNet is image with 3 layers with RGB, and the LeNet maybe one image only have one layer. Okay, maybe it's black and white image. And here is the structure of the different algorithm. And you can say that there are the different is use the different active function, and the convolutional neural network maybe it's in a different size. The input of the image is different. It's 28 times 28, and AlexNet is 224 times 224. All the other algorithm like Swing Transformer, like the ResNet, like the other algorithm usually use this size, and the output is different. You can see here, and the AlexNet use the dropout. Okay, let's move on. Here is the ResNet. Before the algorithm appeared, it was difficult for neural network to have many layers. This is because even if you add more layers, the layer parts of the neural network won't learn anything new. That means I just mentioned that one algorithm is combined with many blocks, and maybe for the first 3 blocks, they can learn a lot of information from the different kinds of image. But the other block, it's hard for the other block to learn other information. But the ResNet can have many layers because it trains parameter with a decimal precision. Then it's them together with the integer part. Finally, it achieves higher accuracy on internet compared to other algorithms. I just remember the outperformance almost all the network in the image classification part, in the image classification area. We can see that at that time, the top one accuracy had already reached the 76.5% maybe. The accuracy was already quite high, but in the recent year, some neural network has been improved based on the swing transformer, but their accuracy is much higher than it. It's around maybe 83%. Well, I also think that many of the other algorithm usually around the 83%. Uh, the algorithm maybe nearly 95%. They use a large algorithm, the large image for pre-train, and then use the image classification for test, for evaluate. Okay, let's move on. FPN. FPN is not an image classification algorithm. I mentioned the FPN is because it uses the pyramid structure. The algorithm related to the swing transformer tend to use this structure. This structure can capture the information at a different level. What that means? That means if you have an image, there are so many objects in the image. Maybe some object is small, some object is very big. So if you use this structure, you can capture the different size. You can also capture the big object, and you can capture the middle object and small object. And the swing transformer, maybe the Biformer and other algorithm, you already use this, but maybe the convolutional neural network didn't use at the first time. Okay, let's move on. And this one is the vision transformer. It can be understood as an algorithm that can compute the relationship between all pixels. A more accurate way to say it's not the pixels, it's patches. It's divided the image into n patch, and each patch is reshaped and projected into d-dimensional embedding. What that means? If you have an image, big image, you can divide this big image into many small patch, and you can maybe make one small patch to reshape in a 2 times maybe 128 new array for the other calculation. And each patch needs to have the position information added, similar to how it was originally used in the NLP to capture the order of the word in sentence. You have one sentence. There are so many words, and the order of word is very important. So for the vision transformer, the order for each patch, like first patch, second patch, third patch, is very important. And this algorithm uses some way to add them together. Okay, and then put this information to the multi-head self-attention and feed forward neural network layer to calculate the relationship between each patch. And finally, a special class token is used for the classification. This token is usually for before the first patch. I just remember. Okay, let's move on. The last algorithm is swing transformer. It is somewhat like using a convolutional neural network to capture the feature and then feed them into the vision transformer. Actually, this structure is not use a convolutional neural network. It just look like or looks similar. However, the lead algorithm directly use the convolutional neural network instead of the original operation. So for the swing transformer, maybe they build a new operation to do similar things like the convolutional neural network. And the other algorithm say that, oh, it's very similar with the CNN. So maybe let me try a new CNN to replace your old operation, and maybe the output is similar. Many of the statements are now completely accuracy. Are not completely accurate. That means all of the things I talk about, maybe it's something is not correct, but I think the overall idea is correct. Okay. Let's move on. In recent years, many algorithms integrate the vision transformer and convolutional neural network together. Most focus on the optimization and improvement rather than the groundbreaking innovation. We can see from the history that many algorithms are end-to-end neural network. What means the end-to-end neural network? That means the input is image and the output is the classes. This mainly because the convolutional neural network achieve excellent accuracy. The algorithm before the convolutional neural network, that means before the AlexNet, the AlexNet is we mentioned in the first algorithm we talked about. It is more dependent on the feature extraction. In modern deep learning algorithm, the end-to-end network can automatically learning feature. However, handcrafted features such as the design features, existing knowledge, or data from the different sources can still help to improve the network's performance. Here are some examples. You can see that these different algorithms can actually the different kinds of the information from different way. Okay, let's move on. Here, before diving into the algorithm, let me first talk about an experiment. The following images are from the COCO dataset. We can clearly see that one of the images have no background. We know that the COCO dataset contains the information on both object detection and image classification. So first, we use the object detection data to crop the objects from the original image, and then we use the segmentation data to remove the background of the object. We can see that the first image and the third image is the original image, and then the second one and the fourth one, I remove the background. Okay. Next, I put both the background remove image and the original image into a same neural network for training and test. The neural network I choose is the swing transformer and the vision transformer. Yes. For the image, we can clearly see that both top 1 accuracy and top 5 accuracy are higher when the background is removed compared to the original dataset. And the dataset without the background has a lower loss value. For now, the problem is this kind of dataset is not available. No one will help us to remove the image background. It's hard because the COCO dataset is labeled by human, but it's hard for me or for the algorithm to do like that. So we need to find a new way. In my opinion, I think the deep information is very important for algorithm to do the image classification. Well, can we use the deep information to divide the image into foreground and background? And then we can use one neural network to learn the feature like the object color, texture, or the other feature, while the other algorithm learns the contour information. The image above shows that the neural network, the original neural network, which is an end-to-end structure, and in the image below, the input is divided into two different images and sent into two different neural networks. At the end, the output will aid them together. I got the depth information using a depth estimation algorithm. The name of the algorithm is not very important because whatever the algorithm we use, the results are poor. Okay. Here is some basic information, like the dataset is ImageNet 100, 1000, and the loss function, the batch size, the approach, and the input size, and others. Okay, let's move on. As shown in the image, the dual path model learns faster at the beginning of the training, but at the end, the single path model has higher accuracy, which means the dual path model do not perform well on the new dataset. Even though both models have similar test loss, the dual-path model's training loss is much lower. That means the model maybe is overfitting. So overall, in this experiment, the performance of the single path model is better than the dual path model. Okay, let's move on to the conclusion. The structure of the algorithm, I think maybe is fine. I don't know. And I also think the main issue of the is the Deep's estimation algorithm, because this algorithm do not effectively to distinguish between the foreground and background. And the other reason maybe is in some image, the objects may not have a clear foreground and background relationship. I choose the image classification because one image only have one object, so it can use this way. If you use the Coco dataset, maybe it's hard to use because maybe in the Coco dataset, one image there are so many objects in one image. And I also think the computer vision still have a lot of room to improve it. That means maybe you can say the deep estimate algorithm. Maybe all of these algorithms are not work very well in this area. Okay, let's move on. I actually did some other research too, but all of these results are not very well. This one you can see here is X-sim. What means the X-sim? That means both of the images like this one and this one are the original images as the input. Like this original image and this original image as input and compare and combine them together. And compare with maybe with this one. This one compare with the same input, this one. Okay. Oh, sorry. And you can say that maybe if you use the two different original image as input, it not works very well. And I also test maybe this is two same images as input. All the time the false image as input. If you use false image, the result is it's hard to see actually. Okay, that's the end of my presentation. Thank you everyone.